Hello everyone, thank you for joining me today for this quick review of Chapter 13. Objectives today, objectives from the chapter: sketching angles of rotation, converting back and forth between degrees and radians, identifying coterminal angles, evaluating cosine and sine, and graphing cosine and sine. Let's start with that concept of coterminal angles. These are angles that share the same terminal side, and so their measures differ by a multiple of 360 degrees. So to take 570 degrees and to find one positive and one negative coterminal angle, we can either add 360 degrees, subtract 360 degrees, or do that multiple times. So even if I subtract 360 from 570, I'm still going to have a positive angle here of 210 degrees. And so that's one positive coterminal angle. There's infinitely many others we could have gotten by adding 360 as well, multiple times. I can take and subtract 360 again to find a negative coterminal angle now. And we're looking at negative, 150 on that. I could continue subtracting 360 to find more negative coterminal angles, and so there really are infinitely many answers to such a question as this. With negative 800, to find a positive coterminal angle, I'm going to have to add 360 multiple times, right? If I take negative 800 and add 360 just one time, I'm looking at negative 440. So there's, one possible answer for a negative coterminal angle. If I add 360 again, I still have a negative 80, so that could be another negative angle there. And if I add 360 one more time, now I have positive 280. That's the first positive coterminal angle, and we could continue adding 360 to find more. Infinitely many answers to such a question as this. It's important that we're able to convert back and forth between degrees and radians as well. So we'll practice that here, starting with 600 degrees. To convert from degrees to radians, we multiply by pi over 180. Okay, we can do a little bit of cross simplifying here to help ourselves out. For instance, I know that both of these are divisible by 60 for sure, right? And this would turn into 3 if we did that. This would turn into 10. So we're looking at 10 pi over 3 radians here, an angle of 600 degrees. Going in the other direction now, we have to multiply by the reciprocal of that conversion factor. So instead of multiplying by pi over 180, we'll multiply by 180 over pi. Well, cross simplifying here too, our pi's cancel out, 5 and 180. We can do that here. This would be 1 and 36, I suppose. And now 6 times 36, multiplying straight across there. We're looking at negative 216 degrees. Biggest thing that could be messed up here is just multiplying by the wrong conversion factor. Pi over 180 versus 180 over pi. Now let's do a little bit of evaluating sine and cosine here. We got a couple angles in degrees, couple angles in radians here. We'll find the exact value here, no decimals. We'll find the exact value by drawing in our reference triangles. So zooming in on 210 degrees here, first thing I'll do is I'll draw in my estimate of 210 degrees, somewhere right about here. Draw my reference triangle back to the x-axis. Okay, and this is a 30, 60, 90 triangle here. Okay. Our answers are the coordinates of this purple point. Those are our values for cosine and sine. In other words, we need this x distance and this y distance right here. Well, remember our hypotenuse, we choose to be 1 here to simplify our calculations. Across from the smaller angle, the 30-degree angle, is a side length of 1/2 here. Consider that to be negative because that coordinate is underneath the x-axis. Okay, across from the 60-degree angle is radical 3 over 2. We'll consider that to be negative as well because that is to the left of the origin. So our answers now: cosine of 210 degrees, negative radical 3 over 2. Sine of 210 degrees, negative 1/2. Moving on to 720 degrees here, we'll sketch that in. 720, if I go around once, that's 360. Go around twice is 720. So the terminal side of this angle falls right here on this positive x-axis. And we still want the coordinates of this purple point here, right? And draw it in such that it falls on that unit circle. That's my attempt at a circle anyway. Yikes. One more time? Not much better at all. Anyway, remember the unit circle has a radius of 1, and so this coordinate being 1 unit to the right here would have an x-coordinate of 1. It is on the x-axis, and so the y-coordinate would be 0. So cosine of 720 degrees is 1, sine of 720 degrees is 0, one of those quadrantial angles there. Finally, 3 pi over 4 radians. The first thing we might do is convert this to degrees like we just practiced, and in doing so, we would find that this is 135 degrees. The terminal side there would fall back in quadrant 2, and I draw in my reference triangle here, and 135 degrees would be 45 degrees short of 180. So we've got a 45, 45, 90 here. Hypotenuse is always 1. We do that to simplify our calculations. Across from the 45 degree angle here, we both have radical 2 over 2. We got to consider this one negative because that's a negative x distance to the left of the origin. So cosine of 135 degrees is negative radical 2 over 2. Sine is positive radical 2 over 2. Multiple choice questions here. We're looking at plus or minus 1, plus or minus 1/2, plus or minus radical 2 over 2, plus or minus radical 3 over 2, or 0 as answers for such questions. We'll finish with a little bit of graphing here. That's how we finish this chapter. So here is y equals negative 2 sine of 4x. We'll sketch 2 periods of this function in the positive direction. And to do so, it helps us to start by finding the amplitude and period. Now remember, the amplitude is the absolute value of this number in front, causing that vertical stretch. We take the absolute value because the negative will cause a reflection. More on that in a little bit. But the amplitude here is just positive 2. To find the period, we take any number that's multiplied to x in here, and we call that b when we learned this. Okay, and we take our default period, which is 2 pi, and divide by that. So here, 2 pi divided by 4, which reduces to pi over 2. Okay, now we talked about graphing this in a very specific way to make it repeatable and efficient, where we take the length of one period and we make that 4 units on our x-axis scale. The idea was every fourth of the way through a period, we have one of those landmark points, those quadrantial angles, whose sine and cosine values are integers, and therefore easier to graph with accuracy. All right, so I'll start plotting some points here now. Sine of 0 is 0, so our sine wave will start here. Okay, now to follow our sine pattern here, normally we would head up to the maximum here, but we have this reflection in front, so we're going to head down to the minimum, and with an amplitude of 2, that will be down at negative 2. Now we just follow our sine wave pattern to graph 2 periods of this function. We want nice rolling hills here. We don't want those sharp peaks. Sine and cosine are not linear functions put together. The slope changes from instant to instant, giving us a curved shape, and that's my best attempt at it there. The domain, although we only graph 2 periods, really this function would continue to the right and left forever. So our domain is all real numbers. Our range is not all real numbers. Our lowest y value is negative 2, and our highest y value is positive 2. Got to label your x-axis scale. What I've done in blue there, that's how we understand how the period changes with that b value multiplied on the inside. One final example here with cosine. I'll try to pick up the pace a little bit here. Our amplitude will be the absolute value of 1.5, which is just 1.5. Okay. For our period, there's no number multiplied on the inside, technically a 1, I guess, right? And so even if we did 2 pi divided by 1, we would still have that default period of 2 pi. So we'll go out 4 units on our x-axis and make that worth 1 period. Here's now 2 periods. Take advantage of those quadrantial angles, those landmark points that happen every fourth of the way through a period. Now cosine of 0 is not 0. Cosine of 0 is 1, and if we multiply that by 1.5, we'll be stretched up here to 1.5. Okay. Now if you rotate a fourth of the way around the unit circle, now we have a cosine value of 0. Another fourth of the way, cosine would be negative 1, but stretched by 1.5, we'll be at negative 1.5. Another fourth of the way, cosine's back to 0, and then we finish off one period, not up there, sorry, back to the maximum at 1.5 in this case. From there, we can just follow our pattern to graph 2 periods of this cosine function. Smooth rolling hills here, not sharp peaks. Domain for this one is all reals again. We only graphed 2 periods, but we could have continued going to the left and right forever. Here our range, the lowest y value is negative 1.5, the highest y value is 1.5, and this wave hits everything in between. It is continuous that way. So there we reviewed our major concepts from chapter 13. Thank you for watching.